Hello, the topic of this project is indexing and searching distributed data with Solr. And the goal of the project is to demonstrate how the data stored in the Hadoop distributed file system can be indexed and searched via Solr. So the way I wanted to show this is to first start with the local setup when you have everything Solr and Tomcat deployed and configured locally on your laptop, and then move on and evolve this setup into the truly distributed indexing of the HDFS data on a CentOS VM. So the steps we will go through are as following. First, we will do the installation and configuration of Solr on the Tomcat on Windows. Then we will review the data that we will be using, and we will discuss some of the design decisions that we need to do to create a Solr schema. Then we will develop a local indexer class on Windows in Eclipse and do the indexing of the data. And we will see what kind of searches we can do in Solr once the data is indexed. Then we will move on to the CentOS VM and we will repeat the same setup of Solr on Tomcat and verify that we can still index the data using the local indexer and get the same results. And then we will move on to the development of a distributed indexer, which is the most important, the most interesting part. We should be reading data from HDFS and indexing the data into the local Solr server running on your VM. And then we will see where we can go from there. Where do we start with the local installation and configuration of Solr? Most likely, you will want to deploy your Solr server not on the example Solr server that is provided with the distribution, but probably on something else like Tomcat or some other web server of your choice. So that's why I decided to show you the installation and configuration for Tomcat. First, you need to download Solr, latest version, and you unzip it into any directory of your choice. Here, the directory is Solr 421. Then you need to create a separate directory for Solr Home. That's where actually all the index data will be and where the configuration of your server will be stored as well. To start with, we just can copy the example Solr server that is provided in the distribution into your new Solr home. Then we need to get Tomcat and unzip the file, the Tomcat distribution binary anywhere you want. In this case, I picked this directory, Apache Tomcat 7032. And that directory will be referred to as Catalina Home going forward. Then we need to move to deploy the Solr web application on the Tomcat. To do that, you need to copy the Solr war file from the Solr's distribution. It's the Solr 421 war in my case, and you need to rename it into the solr.war and place it under the Tomcat's web apps directory. Then you need to do some additional configuration for Solr. In particular, you need to modify the solr config.xml file. There you need to basically update the directory locations where your Solr is installed, and you need to specify the data directory where Solr can store the indexes. Then we need to also create a special file for Tomcat to let Tomcat know that there is a new web application that requires some additional environment parameters. You do that by creating a solr.conf file, and this is the full content of this file. And you just need to modify here the location of your solr.war file. So once that is done, then we are ready to start Tomcat, which is very simple, just by doing the Catalina Home bin startup.page script. And we can access Solr by running, we can access Solr and see if it is running by going to the Solr's admin console on this URL. So in my setup, this is where the Solr is. So we can go into the dashboard and we can see the information about the Solr server. So here it basically tells you what instance you have running, and your Solr instance here is named collection 1. I just didn't change that, and also where your data is stored. So next Let's look at the data that we will be using. For this project, I decided to use the group lens data, which is the movie ratings data. And out of all the different data sets that they have there, I picked just 3. It's the data itself, which is the ratings, the user data, and the item data. And as you can see here, the file structure is such that each line has the tab separated fields, which are attributes of that particular subject, movies, users, or their data ratings, and they can be cross-referenced by their IDs. And this is something that is very important to consider when designing the Solr schema. And Solr schema is basically something that tells Solr what fields should be expected from the documents when they're indexed, and it also determines which data you can search your content by later on when the data is indexed. So designing Solr schema is pretty important, and you have to decide up front what unique IDs you're going to use and how you're going to join the dataset if you have more than one dataset on the Solr server. So in the case of this test data, I decided to use the user ID and item ID as parts of the unique IDs, because just by itself they cannot be used as unique IDs because they would not be then unique across all the data sets. And the schema that I came up with was to prepend the dataset name to the actual new unique ID field in Solr. And in case of the ratings dataset, you also have to use both user ID and item ID as part of the unique ID, otherwise it's just not going to be unique. Another consideration that you have to pay attention to is how you name your fields, especially those that you want to join by. In Solr, there is a join mechanism that is using the local parameter queries, and if you want to use that mechanism to join 2 data sets, you can only join 2. Then the field names have to be different, even though the actual content is the same. So that is why I had to name fields in different data sets differently. User number becomes user number underscore u for the user data set, and item number becomes item number underscore I for the item data set. And I left them as user number and item number in the ratings data set. And the final schema looks like this. That's the final design schema that I did for the Solr server, and you have to add all that information into your Solr server schema.xml file. Okay, so once you have that, we are ready now to develop the local indexer, local Solr indexer. What does the indexer does? It basically will be creating a one document per each line that will be read from each of the data sets. It will be parsing the data from the line, creating a field object for each item, and adding those fields to the document, and then adding the document to the Solr to index. So the important parts of the code are shown here. Basically, we have, as you can see, you just get the line, you create a Solr input document per each line of the code, to each line from the data set. You parse it, and you create a field and add that field to the document. So in this particular application, I decided to use the HTTP Solr server class to connect to the running Solr server via HTTP. And you have to specify the location of the Solr server. So this is what is done here, using the port and basically name Solr. Solr is the name of the web application that is deployed on the Tomcat. You also need to add all the Solr libraries into your either Eclipse or whatever other IDE you use into the class path. So as you can see here, I have all the Solr libraries here. They were added to the class path. And then you can just run the indexer and specify the input as the movie lenses data, the directory that contains those files. Once it is done, again, we can access Solr via the admin console, and we can try to run some queries. And one of the queries that involves joins between the data sets is, for example, find me all action movies and tell me how many ratings of 1 star I have for them, how many ratings of 2 stars I have. So basically give me the rating counts and group them by the rating value for the movies of type action, and do the sorting in the ascending order. So this is a query that I've already prepared here, and after you run this query, so you can create the queries just by populating the fields in the Solr's admin console. So here I specify the join, this is the filter query. Here I specify the grouping parameters, and here I'm specifying what I want to sort by. And then you can execute the query, and once you execute it, you get the result. And you can see that, for example, for action movies, you have 1,546 ratings of 1 star, 3,254 of 2 stars, or you have more of 3 stars, 7,000, almost 8,000 of 4, and 5,000 of 5. So you have more good ratings than bad ratings. I guess this is good. So now we are ready to move onto the Tomcat and Solr install on CentOS VM. It's actually very similar to Windows. All you need to do there is the same stuff. You just need to get the distributables this time in the Linux format. You untar them into whatever directory you want. You set the Catalina home env variable in your users.bash profile. That a convenience, but it's pretty useful. And you set the Catalina home to your location, installation location of your Tomcat. One thing is that you have to modify the default Tomcat's port from 8080 to something else, because Cloudera is already using that port for its own web server, and we already have the Cloudera's Hadoop distribution on that VM. So just change it to something else. I change it to 8090, and you do that in the server.xml file of your Tomcat installation. And the rest of the setup is exactly the same as what you've done on Windows, so I'm not going to go through that. And then you just start Tomcat using the same command pretty much. It's Catalina home being startup sh, and you can access the Solr admin console via the new URL, which has a different port. And once you access, you will see that you can do this. You will see that the server is running. So now we want to run the same indexing, do the same indexing of data on CentOS VM. So to do that, we move our code that we already developed for the Solr local indexer onto the CentOS VM. And you need to modify the URL in your code to point to the correct Tomcat port 8090. And then just for convenience, I've created 2 scripts to compile and run this class. And the only thing that you need to do there is to really define where your Solr libraries are and add them to the class path. So once you do that and you run your local indexer, then you will see that the user data will be indexed and added to the Solr. So on CentOS, I only indexed user data first using the local indexer because I wanted then to index the rest of the data from HDFS using the distributed indexer to show that the data are the same. So when you just index user data, you only can run limited queries just for the user data set. And one of the queries that I tried was find me all students and show me how many users you have in this data set per zip code. Basically just group all the users whose occupation is student and show those counts. And you can see, for example, here that for the zip code 01002, you have only 1 student, and actually for others, there were not that many more either. So now the most interesting part, we can now move onto the distributed indexer. So what is distributed indexer? Basically, we'll have to develop a MapReduce job that would be reading the input data from the same data sets, create the Solr documents per each line, and submit those documents for indexing to the Solr server. So I decided to develop all the Java code in Eclipse first on my Windows machine, and then just move them to the VM. To develop the MapReduce jobs, you have to make sure that you add the Hadoop libraries as well into your project's class path. So like here, for example, I have the Hadoop libraries, as you can see. They are also added to the project. And then you need to decide how you want to develop your MapReduce jobs. So one design decision that I made was to develop a separate indexer for each dataset. And the reason for that is that when the mapper gets input, which is just one line from a file, it's pretty hard to tell which dataset that line is from. And because the formats for each data sets are different, actually. Some are tab delimited, some are vertical line delimited, and they have different number of fields as well. It's important to know which data set you are processing to correctly parse the data. So it was easier to just develop a separate indexer for each data set. Then the mapper itself, basically what it will be doing, it will be creating a document per line. Whatever line it gets, it will create a document, it will parse it, and it will create a document and submit it to the Solr server. Just the same thing that the local indexer was doing. But what it means is that there is no real output from the mapper, and it means that we can just use the null writable as the output type for the mapper. Another point to consider is that we also do not need any reducers, because all the job is done in the mapper. We don't really care about what is happening afterwards. Then you also need to think about where you are going to initialize your connection to the Solr server. And when are you going to commit all the changes, all the index documents to the Solr server as well? You don't want to do this per document. That's a very expensive operation. You really want to kind of batch up all those index documents and commit them once after all of them are done. So to do that, I used the callback methods that are provided in the MapReduce libraries, and they are called setup and cleanup, as you can see here. They are marked with an override. Basically, I used the setup callback method to initialize my server connection to the Solr server, and I used the cleanup method to commit all the changes, all the index documents to the Solr server once all the mapper jobs were done. So this code you can also see maybe in more details here. For example, this is a Solr indexer, and you can see that in the initializer we do the init server, we define the user fields, and then in the cleanup we commit all the changes. And the actual job is done really in the mapper, where you take one line of input, you parse it, and for that I use the same methods that I developed for the local indexer, where you just process one line, parse it, and create the document object for Solr. So once the code is developed, I moved it all into the CentOS VM and packaged it there. And the reason for that was that I needed to include the Solr jars, third-party jars, into the MapReduce job itself as well. Otherwise, my classes could not access them. So the only way to do that I found was to just package them as part of the actual MapReduce job jar. So I did that by creating a separate directory lib and copying all the Solr jars in there, as you see here. And then I created a script, a small script that was basically creating a jar by packing all the jars from the lib directory and all my compiled classes. So then I moved the data from the local directory into a HDFS by using the normal command fs-put and then your directory name, and we are ready to run the job. So you run the job just in a normal way. As you run any Hadoop job, you specify the name of the jar, and you specify the name of the class that you are running, And because we have a separate indexer per each data set, you have to basically run 3 jobs. You first run the user indexer, then you run the item indexer, and then you run the data indexer using the different input data and output directories. And the output itself is not that interesting because it's empty as expected, because our mapper does not produce any output into the file system. So once those jobs ran and produced and basically did what they were designed to do, indexing data, now we can access the Solr server on the CentOS VM and verify that we have exactly the same results as before we had on Windows Server. So that's why I wanted to run the same query. I basically wanted again to get all the counts of ratings for the action movies as we did before in Windows. So if you run this query on the CentOS server, which we will access now, then we will see that the results are exactly the same. So we have exactly the same counts here for the ratings of 1 star, for ratings of 2 star, and so forth. So we successfully indexed the data from the HDFS file system, and we were able to search it in the local Solr server. So where do we go from there? Well, the current approach has some serious limitations. First of all, we see that we could only join the data sets, only 2 data sets at a time. The way to go about that is to usually denormalize the data and just copy data into like one huge document from all the data sets. And yeah, you'll have a lot of basically data duplication, and your data size will explode. But that's one way to analyze all data in the dataset. Of course, the jobs would have to be modified, because now you have to process all the data together and join them by different IDs. So you have to figure out then how you can basically keep updating the same document in Solr by processing different parts basically of the document, and different parts would be from different data sets. Another way to do that would be to create multiple indexes for different data sets and put them on different Solr cores. And that's what Solr Cloud project is about. Also, the other limitation is this scalability. Right now, the data that we process is distributed in HDFS. However, the Solr index itself is not distributed, because it is all stored on the local file system, and it's subject to the same limitations as the local file system is. And the Solr server itself is only a single node server and can fail if that server fails. So we would definitely want to distribute that as well. So that's why probably the next logical step would be to look into the using Solr Cloud, which does just that. It does the distributed indexing. It distributes the index, it shards it over multiple nodes, and it does the same for the Solr server. Another limitation is how we feed the data into Solr. Right now, every time when you add new data, you have to run those indexers and add the data to the Solr index. I think it would be much better if we could have some automated way of doing that. And probably some interesting projects to look into that might help would be Flume, Hadoop streaming, or maybe something else. There are many new technologies that are coming up that would allow some streaming, that provide capabilities for streaming and database processing. A different approach to the distributed search is the Cloudera's Impala project, which is also a very interesting technology, and it does not use actually the same kind of index that is done by Solr or Lucene. So that is also something that would be interesting to look into. So that concludes my presentation for this project.